Okay, so let's make sure we understand the directions here. What we need to be able to do is find the vertex and then 4 more points. The next 2 points, so if the vertex is, let's just say 0, 0, what I'm going for is I want 1 unit to the right and to the left of that. So if you go over 1, you'd go up 1. And if you'd go left 1, you'd also go up 1, something like that. And then the other one are 2 units. So if you go over 2, you would go up 4, and if you go over 2, you would go up 4. And if it wanted some more, it would be 3, 9, and negative 3, 9, like that. So parabolas, and the next point would be 4 over 16 up, and then so on and so on. So I want the vertex, 1 to the left, 1 to the right, 2 to the left, 2 to the right. That's what these are trying to say. So we want that point. So for this particular one, we can see that the y's right there are times 1/4. So that would go over 1, instead of over 1, up 1, it would go over 1, up 1/4. That's what that one is trying to say right there. And then we go over 1 this way and up 1/4. That's what that one right there is. So 3, and then it would go over 2. Instead of going over 2, 4. The 4 is 1/4, so it would go over 2, up 1. That's what that one is. And over 2, up 1. That's what that one is. So those 5 points. Okay. So this one is in transitive form. So the stretch kind of numbers are on the letters that they're already with. So this has an x stretch that's just normal. And it has a y stretch times 3. So the y values are 3 times taller than normal. So instead of going over 1, up 1, we're going to go over 1, up 3. So here's the vertex at 4, negative 2. Okay, 4, negative 2 is right here. So it looks like this one's going to fit. Okay, so usually, so it's like the 0, 0. Usually we go over 1, up 1, but the y part is tripled, so it's going to go over 1, up 3. So over 1, up 1, 2, 3, and over 1, up 1, 2, 3. Those are the next 2 locations. You can count it. That dot right there is at 5, 1. So see how that one, we went over 1 from the vertex to made it 5. Then we went up 3. Then the other dot, from the 4 we went left 1, making it a 3, and then the y part went up 3. So there's those 2 positions. Then we would normally go 2, 4, but the y is getting tripled, so 4 times 3, so we're going to go over 2, up 12. Okay, so from the vertex over 2, up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's right there. And then go left 2, up 12, puts it right there. So you could count and see where those 2 dots are. I just like to do it from the vertex. So the vertex was 4. I went over 2, so that one must be at 6. Then we went up 12 from here, so that must be at 10. That dot must be at 6, 10, and sure enough, 6, 10 is where it is. And then from the vertex I went left 2, so that must have put it at 2, and up 12, so that puts that one at 10, and sure enough 2, 10 is where that one is. So that's what I'm looking for the graph and those 5 specific, what are those 5 specific dots, just like on all the quizzes. Okay, go ahead and do number 2. I'll give you the answer to, I'll do number 2. Try to pause and just do it yourself and then check it. So number 2 is half as tall. So instead of going over 1, up 1, we went over 1, up a half. And then over 2, instead of over 2, up 4, we went over 2, up half of 4, which is 2. Okay, number 3 is basically the same thing. I'm just going to move some of these things around. Now, it's fine if you get to, so you don't have to move them around. But here's where this comes from. If we move the 3 to the other side, it would be y minus 3. And if I divide both sides by -2, this would be -1/2. So technically I'm dividing by -2, dividing by -2, and moving the 3 over. So you can always turn it to the same form as number 1. And now what that's showing us is, okay, the multiplicative inverse is -2. So the y's are going to get doubled but go down. Now I'm certainly understand I'm fine if you leave it the way it is. That number right there, if it's not inside the parentheses, is always the y multiplier. If you haven't noticed that by now, that number, if you do, because we have to divide it to the other side and then we do the inverse. It's like doing the inverse twice gets it back to that -2. Okay, so the vertex is at -2 for the x and +3 for the y. So the y's are going to get multiplied by -2. So -2, 3, 1, 2, 1, 2, 3 right there. So it's supposed to go over 1, up 1, but the y's are getting negative doubled. So it's going to go over 1, down 2. So over 1, down 2, over 1, down 2. So from here, one of those points, if I go to the right, that'd be at -1 and then down 2. So that one of them must be at -1, 1. Sure is. And then from the vertex, if I go the other way, it's at -3, down 2. -3, 1 is where that one is. Okay, then you're supposed to go 2, 4, but again, the y is getting negative doubled, so it's going to be 2, -8. So from the vertex, I'm going to go over 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, down 8. So starting at the vertex, if I go over 2, that's going to put it at 0. And then down 8 from 3 puts that at -5, which is that one right there. And then if I go 2 the other way, -2 go 2 the other way is at -4, and 3 down 8 is -5, which is that one. Number 4. So there's no multipliers. So the y's are just normal, the x's are normal. And so if you want to put the 1 to the other side so you can see the vertex easier, you can. If you just can see it from here, that's fine also. But the vertex is at +4, -1. +4, -1. 4, -1. And then this one has got a normal kind of a slope. Everything, there's no multiplier. So over 1, up 1, over 1, up 1. So over 1, up 1 is it. It doesn't get changed. So it's those two. So from the 4, if we go over 1, it's 5. From the 4, if we go over 1 the other way, it's 3. Then we're going, on the y's, we're going up 1. So -1, up 1 is 0 for both of them. And that's where both of those dots come from. Okay, then I got to go over 2, up 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So from the vertex, I went over 2, making that a 6. Go over 2 the other way. 4 so 4 plus 2 is the 6. 4 minus 2 is the 2. And then for the y's, we went up 4. So for the y part, the -1 going up 4 is 3, which is that dot and that dot. Okay, number 5 is in standard form, so we gotta fix it first. So I'm going to go ahead and complete the square so I can get it in the form where we can see what the vertex is. Okay, let's see here. I'm going to move the 7 to the other side, where I need some space to do all of this. So I'll move the 7 to the other side. Let me grab a piece of scratch paper somewhere. Now, I would want to see all of this work so I can see how you're doing it. I'm going to move the 7 to the other side. So y minus 7 is 2x squared minus 8x. You got to factor out that 2. That's going to become the multiplier. Dividing a 2 out of that leaves x squared. Dividing a 2 out of that leaves 4x. Then we cut this in half. Negative 2. Square it. Negative 2 squared is plus 4. So I added 4 to this side, but it's not really 4. It's 2 times 4. So I added 8 to this side, so I have to add 8 to that side to keep it balanced. So added 8 here, add 8 there. So we have y plus 1. Then I've got that multiplier of a 2. And now this 2 becomes the shift, x minus 2 all squared. Okay, so this is the y multiplier. The y's are going to be times 2. And then this and this are the vertex. So the vertex is at 2, negative 1 with a y multiplier of 2. Now why is that the y multiplier of 2? Because it's not inside the parentheses. So you can just recognize that that's the y. It's not connected to the x, so it is the y. Or we could divide both sides by 2 and it would become 1/2 over there, y plus 1, and then x minus 2 all squared. See, now that's the inverse. The y's are multiplied by 2. And then the vertex is at positive 2 and negative 1. So whichever way you want to think about it, that's all fine. So the y's are twice as tall, so this is going to be twice as tall, starting at that vertex 2, negative 1. So there's the vertex 2, negative 1. Okay. Typically, I would go over 1, up 1, but the y's were doubled, so it's going to be over 1, up 2. So over 1, up 2, over 1, up 2. So for the x, if I go positive 1, that's a 3. If I go to the left 1, that's a 1. So 2 plus 1 and 2 minus 1. That's the over 1. The x is the over part. Now I got to go up 2. So negative 1 up 2 is positive 1. And that's both of those dots right there. That's where they come from. Then the next non-stretched position would be at 2, 4, but the y is getting doubled, so it'll be at 2, 8. So over 2, up 8, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And over 2, up 8. So thinking of it from the vertex, if I go plus 2 from that x, puts it at 4. If I go minus 2 from that x, it puts it at 0. Then for the y part, we went up 8. So negative 1 up 8 is 7 for both of them, which sure enough are those 2 dots. Okay, number 6, I'm going to complete the square for that one. Okay, so I'll move the 4 to the other side. So y plus 4 equals negative 1/2 x squared plus 4x. Now I got to divide everybody by negative 1/2. So y plus 4, I'm going to divide out the negative 1/2. So this term is, so it has an a term of 1. So all of this divided by negative 1/2 is positive 1x squared. 4 divided by negative 1/2. 4 divided by negative 1/2 is the same thing as 4 times negative 2. So that 4x becomes a negative 8x. 4 divided by 1/2 is 8. Okay, you cut this one in half, negative 4. Square that into the whole. Negative 4 times negative 4 is positive 16. So it looks like I added 16 to this side, I add 16 to this side, but it's really 16 times negative 1/2. So altogether, I really added negative 8. If I add negative 8 here, I add negative 8 over there. So we have y minus 4 equals negative 1/2 x. Here's the factored part now. That's why we write it down. It becomes the x shift. So there's the y multiplier. The y's are going to get multiplied by negative 1/2. The x, there's the vertex. The vertex will be at positive 4 from that and positive 4 from that. So vertex at 4, 4 with the y's multiplier of negative 1/2. So we have 4, 4. I'm going to remember that the y's are multiplied by negative half. Okay, so instead of going over 1, up 1, I'll go over 1, down 1 half. So over 1, down a half, over 1, down a half. So from the vertex, positive to the right 1 makes it 5, to the left 1 makes it 3. I went down a half, so 4 down a half is 3 1/2. Which is where those 2 points ended up. Okay, then I should go 2, 4, but the y's are getting multiplied by negative half, so that times negative half makes 2, negative 2. So over 2 down 2, over 2 down 2. So from the vertex, I went to the right 2, makes it 6. Go to the left 2, makes it 2. 4 plus 2 and 4 minus 2. And then for the y, I went down 2. So 4 down 2 puts it at 2, which is that dot and that dot. Okay, number 7. Complete the square on number 7. So this one is a less than or equal to, so this one's got some shading involved. Now another way to get the vertex that we could remember is, and I'll let you decide which one, but you'll have to remember it. The beginning of the vertex, remember, was negative b over 2a. And then whatever that number is, you plug it in and that will get you the y. We could do that here. So the a here is 1, the b here is 6, and the c here is 5. Okay, so the vertex would be at negative b, so negative 6 over 2 times a, so 2 times 1 is 2. So the x part of the vertex is negative 3. If I stick negative 3 in all of that, it will tell me what the y is. So if I go and do that on the side here, so it's negative 3 all squared, so there's the x squared, plus 6 times negative 3 plus 5. Negative 3 squared is positive 9, minus 18 plus 5. Oh, what do we have out of that? 14, so negative 4. You could get the vertex that way also. Now I'm going to complete the square just to show you that it would have been the same thing. The problem with this is I don't quite see what the stretch number is. I'll tell you how to get that here, and I'll show you how to complete the square first. If we complete the square, I would move the 5. Okay, cut the 6 in half, square it in. That'll be plus 9. There was no multiplier, so I added 9 there, I'll add 9 there. So we have y plus 4 equals x plus 3 all squared. And sure enough, see, there's the same vertex. The vertex is at negative 3 and negative 4. Okay. Notice what the multiplier ended up being? 1. The multiplier is always the a value when it's like this. So we could tell that the multiplier was 1 right there also. So that's just another piece of advice. You can do it either way. Complete the square and get it, or negative b over 2a is the x value. You can remember that little piece of the formula. It's the beginning of the quadratic formula. The quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. See, it's the beginning of the quadratic formula. Okay, so whichever way you got it, the vertex is at negative 3, negative 4 with a multiplier of 1, so a normal multiplier. Negative 3, negative 4. Okay, so I'll go over 1, up 1. So over 1, up 1, over 1, up 1. So negative 3 plus 1 is negative 2, negative 3 minus 1 is negative 4, and then the negative 4 plus 1, which is where those dots are. Then I'll go over 2, up 4, so 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. So from the negative 3, add 2 is negative 1, negative 3 minus 2 is negative 5, then we went up 4, so negative 4 up 4 puts those at 0, which is, sure enough, where they are. Now, it wants this to be less than. This is a shaded one. It has the little underline under it, so this is a solid line, so I'm good with all of that. Now, it's either going to be shaded on, all the points make it true on the inside, or all of the points make it true on the outside. It doesn't matter. You just have to pick a point. Just for giggles, I'm going to pick this point right here. Looks like I just chose -3, -1. I'm going to test -3, -1, because that's definitely on the inside. Okay, that just means put -3 where there's an x and put a -1 where there's a y and see if it's true. So right there's the y, -1, less than or equal to -3 all squared plus 6 times -3 plus 5. Is -1 less than or equal to 9 minus 18 plus 5? 9, let's see, what we already did this. This was -4, so we have -1 less than or equal to -4. That's either true or false. Is -1 smaller than -4? That is false. We want to shade everything that is true. The point that I tested was false. That means that point does not get shaded, nor does anybody around it. That means the ones outside of that were the ones that would have been true. So if the point you chose was false, then the other points are true. And it doesn't matter which point you pick to test. All of the points on the inside of the parabola would have given you false. All of the points on the outside of parabola would have given you true. Okay, number 8. Don't really have to, this one's already in a nice format. The y is going to get multiplied by -2, and the vertex, it's going to be -4, and it's going to be +4 for the x and -4 for the y, because really that 4 belongs over here, and then it really would have been y minus 4, and the inverse of that, it really would have been y plus 4 if I moved that 4, and the inverse of that is -4. Okay, so the vertex, 4, -4. Okay, so the y is going to get multiplied by -2, so over 1 down 2, over 1 down 2. The vertex, over 1 makes 5, over 1 the other way makes 3. Down 2, so -4 down 2 makes -6, which is where both of those dots are. Okay, that was the 1, 1, which was really 1, -2. 2, 4, but the y has to get negative doubled, so that really will become 2, -8. Over 2 down 8. 1, 2, 3, 4, 5, 6, 7, 8. So I got to go over 2. So the 4 over 2 is 6. 4 over 2 the other way is 2. And then for the y's, I went down 8 from there. So -4 down 8 must have been down 12, which is where those two dots are. Now this one, I take a look at that, is not underlined, so this is a dash. That means the line is false. The line is only the border line that's not true. Okay, over here I tested a point that was inside and got false, so it was the outsides. This time actually my favorite one to test is 0, 0, so I think I'll test right there, 0, 0. That's definitely on the outside. Now if this one is false, it shades the inside. So if it's true, I shade out there. So I'm just going to try 0, 0. I'm going to put a 0 in for the x and a 0 in for the y and see if it makes it true. So 0 less than 2, -2 times 0 minus 4 all squared minus 4. Is that true? Well, let's see. That's 0 less than -2 times -4 squared would be 16 minus 4. -2 times 16 is -32 minus 4. So is 0 less than -36? No, that is false. So now this point out here is false. That means everybody around it is false. Well, if all of the people outside are false, that means all of the points inside are true. So I just got both of the ones that I tried happened to be false. If it would have been true, if I'd have tested a point inside the parabola this time, it would have been true in there, and I just shade everybody around the true. Okay, factor. We're trying to pull these things apart. We have several things to remember here. So, first glance, I see a p in both of them. I can divide a p out of both of them, leaving p times p minus 3. That's factor. Okay, here I'm trying to split this up. I need first, outer, inner, and last. The first times the first, that's the first spot, that's the first spot, that's the first spot. The first times the first has to be the first. Well, v times v equals v squared. Check. This one is the last spot and the last spot. The last times the last has to equal negative 18. So I could do 1 times 18, 2 times 9, or 3 times 6. I pick the combination that can add together, inner outers, that can add those to negative 7. Well, this one right here, if you add it, it becomes 9. If you subtract it, it becomes 3. That could never become 7. Here, if we add, we have 19. If we subtract, we have 17. That could never become 7. Here, if we add, it would become 11, but if we subtract, it could become 7. That's a choice. So it's going to be 2 and 9. Now I need it to add up to negative 7. So here's the inners, 2v. Here's the outers, 9v. They have to add up to negative 7. So the 9 has to be negative, the 2 has to be positive. Negative 9 plus 2 is negative 7, so the 9 has to be negative, the 2 has to be positive. That's how you work out the puzzle. Okay, first I would like to cut all these at least in half. Maybe they can all divide by, I think half is probably all they can do for number 11. I'm going to divide out the 2. That leaves 7n squared plus 30n plus half of 54 is what, 25, 26, 27? Okay, now I would try to see if I can get that thing to go any further. So I'm going to go ahead and try to break this down. There's only one choice for the first. Something that multiplies to 7 is 1n and 7n. For 27, I have two choices. 1 and 27, that's probably not it. And then 3 and 9. So I would probably try the 3 and 9 first in this order. If I take a look at that, that's 21 and that's 9. Sure enough, 21 and 9 can make 30 if I add them both. So if that's a positive and that's a positive, 21 and 9 make 30. So that's a positive, and the 2 is part of it. Okay, number 12. I'm going to divide out the 2 first. They all are even. So that leaves 7n squared minus 41n plus 30. Okay, same idea. I have a 7n times an n. Doesn't matter which one you put first. 7 times 1 is 7n squared. For 30, my choices are 1 and 30. That's probably not it. 2 and 15. 3 and 10. 5 and 6. So there's lots of choices here. Okay, well, I'm going to start to sketch them out here. Let's see. I think I'll start with maybe the 5 and the 6. If I put a 5 there and a 6 there, I get 5 out of that and 42 out of that. 5 and 42 will not make 41. Before I get rid of it, I'm going to switch the order. 5 times 7 is 35 down here now, and then 6 times 1 is 6. 35 and 6. Okay, sure enough, 35 and 6 can actually make negative 41 if I make them both negative. So I'll make the insides negative 6, the outsides negative 35, negative and negative. So that makes they add up to negative 41, and negative 6 times negative 5 is still positive 30 with the 2 in the front. Okay, 180, well, 45, can I take a 45 out of that in the first place? 180 divided by 45 is 4. Okay, so good, I can first of all divide out 45. Okay, really what that is x squared plus 0x minus 4. I'm trying to split that 4 so that it adds up to nothing. Well, 2 and 2 will add up to nothing. It'll either add up to 4 or it'll subtract up to nothing. So this actually does have an answer. If I stick a 2 in both of them, see if I make that a negative 2 and that a positive 2, they'll add up to 0 for the middle. So one of them has to be plus and one of them has to be minus. And notice that positive 2 times negative 2 is still negative 4. So the 45 comes out, and then that's x minus 2 and x plus 2. That's called a perfect square. This only works when that number is a perfect square, like 4 or 9, because that could be 3's, or 16 or 25 or 36. If that's a perfect square root and a minus, then it splits into its square roots like that. Okay, let's see if we can take anything out of this 24. Just 189 divided by 24. Okay, not so lucky. 24 can divide by 6. Does 189 divide by 6? No, it'd have to be even. What about 3? Looks like 3 can divide all of those. 24 divided by 3 is 8. 189 divided by 3 is 63. And what was that? 243 is 81. Okay, let's see here. So now I'm gonna get a piece of scratch paper so I can have a little bit more room to try. This one is gonna have some issues, because there's just so many things to try. So the 8 could be 1 and 8, 2 and 4. And the 81 could be 1 and 81, or 3 and 27, or 9 and 9. Okay, lots of combinations here. So maybe I'll try the 2 and 4 first. And I think I'll try the 2 and 4 with the 9 and 9. There's 36, there's 18. 36 and 18 does not make 63, so it's not going to be that one. So I think I'll try the 3 and 27 next. 2 times 27 is 54. 3 times 4 is 12. Is 54 and 12 63? No, it's 66. So before I throw that one out, let me switch this order around. 27 and 3. Now 2 and 3 is 6 on the outside. 27 times 4 is 108 on the inside. That's never going to make 63. So that one doesn't work either. Okay, so I'm pretty sure it's not the 81. 2 times 81 would be a lot. Yeah, it's not going to be the 81. So either I'll give it another try with the 1 and the 8. 1V and 8V. Okay, so I'll start with the 9 and 9 again. 9, 8 times 9 here is 72. Okay, that has a chance. 72 minus 9 happens to be 63. So I need negative 63. So if I make that negative 72 and positive 9, so the 9 is positive and this inside piece had to be negative. Okay. Negative 9 times positive 9 is negative 81. The inner outers make negative 63, and 1 times 8 makes 8. So there it's factored. So it's the 3 on the outside, V minus 9, and 8V plus 9. That's the process. 15. Okay, it doesn't look like anything can divide out of there because of that 19, so I'll just give it a try. So 6 is either 1 and 6 or 2 and 3. 36 is 1 and 36, 2 and 18, 3 and 9, no, 3 and 12, 4 and 9, and 6 and 6. So lots of choices for that one. So I think I'll start with the 2m and 3m. Okay, 6, so I'll start from the bottom and work up. 6 and 6. That's 18 and that's 12. Well, 18 and 12 can never be 19, so it's not 6 and 6. What about 4 and 9? That makes 18 on the outsides and 12 on the insides again. 18 and 12 is not going to do it. So instead of, before I throw it out, I got to switch the order. So 9 and 4. 2 times 4 is 8. 9 times 3 is 27. Okay, 27 minus 8 is 19. So if I can make this a minus 8 and a positive 27. So the 27 right in here has to be positive. This part out here has to be minus. Okay, so 9 times negative 4 is negative 36. The inner outers make 19, and 2 times 3 is that one. So there it is. It's 2m plus 9 and 3m minus 4. (16) 8's possibilities are 1 times 8 and 2 times 4. 81 is 1 times 81 and 3 times 27 and 9 times 9. I'll start with the 2 and the 4, and then also with the 9 and the 9. So there's 36 and there's 18. 36 and 18 will never make 9, so it's not that. How about 3 and 27? 2 times 27 is 54. 3, that's 12. That's never going to do it. What if we go the other way? 27 and 3. 4 times 27 is way too big, so there's no way that's going to do it. And I don't see how 81's ever going to get down to a 9, so I doubt that's going to be it. So 2 and 4 is not going to work. So my only choices then are 1v and 8v. Okay, if I put a 9 and a 9 in there again. 72 and 9, that's never going to be 9. How about 3 and 27? 3 times 8 is 24. That makes 27. 24 and 27 will never be 9. Switch the order to 27 and 3. Okay, 27 times 8, that's never going to be close to 9, so it's not that one. And then 1 and 81, again, that's never going to become 9. So I used up all the combinations of 2 and 4 with all of these, and I tried 1 and 8 with all of these. None of them made a middle term of 9. This one is not factorable. That one does not come apart. Okay, 17. 1 and 16, 2 and 8, 4 and 4 versus 1 and 9, 3 and 3. Now, I see a perfect square there and a perfect square there. When I see that, I always try those first. 4x, 4x, and then 3 and 3. That sometimes is a good clue if they're both perfect squares. So there's 12, and see there's 12. 12 and 12 can make 24 if they're both negative. So if I make them both negative, you just got to check the last one. Did that keep the positive 9? Well, negative 3 times negative 3 is positive 9. The inner outers make negative 24, and 4 and 4 it makes 16. So there's that one. And then I see both of these are perfect squares. They have a 0 in the middle. So you can think of that as 9x squared plus 0x minus 1. They're perfect squares again. That's probably 3x with a 1 and a 3x with a 1, just like the last one. Because 3 times 3 is 9, 1 times 1 is 1, but now they got to add up to 0. So that's 3 and that's 3. Well, you make 1 plus and 1 minus and they add up to 0. And now positive 1 times negative 1 is still negative 1. They add up to 0, and 3 times 3 is 9. Okay, number 16. Find the zeros of each one by using different methods. So for these, I want to see the square root method. So you have to show enough work that I can see that you used the square root method. You must show work to show the square root method. So I'm looking for more than just the answer. I'm looking for the method to go with it. So I need to see enough work I can tell you used the square root method. Okay, so I'm going to get some scratch paper here because I certainly need that on these. So 19, finding the zeros. Well, I'm going to first of all set it equal to 0. So I'm going to move the 10 to the other side. So that will give us 100x squared. So if I subtract 10 over here, it'll be minus 16 equals 0. Okay, the square root method means we're going to break it down to just x squared. So now the method is put the 16 to the other side. So we got 100x squared equals 16. Divide both sides by 100. So we have x squared equals 16 over 100. Here's what it means by the square root method. Square root both sides. So we have x equals plus and minus 4/10. Square root of 16 is 4. Square root of 100 is 10. Those are the two zeros. That means one of the zeros, I'll put a z for 0. That means the x is over 4/10 up 0 and left 4/10 up 0. Those are the two zeros. Now to find the vertex, so those are the zeros. We already have the 0. You can actually plot those if we wanted to. 0.40 and negative 0.40, they're right there. We have those. 0.40 and negative 0.40. Okay, to get the vertex, instead of setting it equal to 0, we set it equal to y. So 100x squared minus 16 equals y. Now we have a couple, you can complete the square to find the vertex, or you can use the formula to find the vertex. If we wanted to complete the square, we'd move it over. I'm going to use the formula. This is 100x squared plus 0x minus 16 equals y. That's the A, 0 is B, that's the C. The vertex formula is negative b over 2a, and then stick that in. Okay, well, negative b, so that's going to be negative 0 over 2 times a. Well, that's 0. Then you take the 0 and stick it in. So if I take the 0 and stick it in up here, it's 100 times 0 squared plus 0 times 0 minus 16. That's 0 plus 0 minus 16. That's a way to get the vertex without completing the square. The other way to get the vertex is the x is always the average between the zeros. It's always the average between those. So what is the average between so the average of 0.4 plus negative 0.4 divided by 2. Well, that's 0 divided by 2. See, that's another way to get the x part. The x part of the vertex is 0. Then stick it in the original equation and get negative 16. So either way you do it, the vertex is at 0, negative 16. So 0, negative 16, it says plot it the best you can, so that's going to be down here someplace. And then 1 unit to the left and 1 unit to the right. Okay, let's take a look at what our equation was up here. If we had completed the square, the a number is the y stretch. The y's would be multiplied by 100. So our next dot should be over 1 up 1. It's going to be over 1 up 100. So from this vertex, we're going to go over 1 up 100, which puts that at 84. and go over 1 the other way, up 100, puts that at 84. So obviously those are way up there. So here's our graph. It's really skinny and really tall. Okay, number 20. Find the zeros by the square root method. So for 20, I have 4n squared. I'll add the 72 to the other side. Plus 79 equals 0. Okay, so I'll move the 79 to the other side. Divide off the 4. Square root both sides. So this is now imaginary. So n is plus and minus imaginary roots of 79 over 2. The square root of 4 is 2. So there are no zeros, no real zeros. That means the picture's going to look something like this. It's not going to touch the x-axis. Okay, so zeros, none. All right, well, let's find the vertex. That's y equals 4n squared plus 0n plus 79. Negative b over 2a, and then stick that in. So negative b will be 0 over 2a. So obviously that's 0. If I stick a 0 in there, I have 4 times 0 squared plus 0 times 0 plus 79. So 0 plus 0, so it's 79. So 0, 79 is the vertex. And right there is the y multiplier. We're going to take the y's times 4. So instead of going over 1, up 1, we're going to go over 1, up 4. So from the vertex, if I go over 1, up 4, puts it at 83. If I go over 1 the other way, negative 1, up 83. Okay, so we'll just do the best we can at graphing that. So 0, 79 is going to be someplace way up there, and then over 1, up 4 more, over 1, up 4 more. It's something way up there. Okay, 21. Now we have to show that we do it by completing the square. So we need to show enough work that we can prove that we know how to complete the square. All right. Let me find some scratch paper here. Here we go. Okay, so let's see here. We have, we'll move this to the other side, so minus 3a squared. So really we have a squared plus 16a. Oops, nope. Minus 4a there, so it's really only 12a. And then add 2 plus 11 equals 0. Okay, complete the square. Let's go. We got to move this little 11. We're kind of moving it out of the way. So a squared plus 12a. Now you can move the 11 to the other side. Cut the 12 in half. Square it into 36. If we add 36 to that side, we got to add 36 to that side. So now we have a plus 6 all squared equals 25. Square root both sides. So that gives us a plus 6. That square root and that square root will cancel out. And over here we have plus n minus 5. Move the 6 to the other side. So we have a equals plus n minus 5 minus 6. Positive 5 minus 6 is negative 1, and negative 5 minus 6 is negative 11. So there are the two zeros. The zeros are negative 1, 0, and negative 11, 0. Okay, so negative 1, 0, and 8, 9, 10, 11, 0. There they are. Okay, the vertex is halfway between those. Okay, well, if the vertex is halfway between them, I've got negative 1 plus negative 11 cut in half. That's negative 12 cut in half. That's negative 6. The vertex is at negative 6 down something. So our vertex is at negative 6. Now I got to figure out what all this stuff is when you stick a negative 6 in there. So you take the negative 6 and you put it back in the original equation. Okay, so negative 6 squared plus 12 times negative 6 plus 11 equals the y, which is what's missing. So that's 36 minus 12 times 6 is what? 72 plus 11. 36 minus 72 plus 11 is negative 25. There's the vertex, negative 6, negative 25. So negative 6, negative 25 is down here somewhere. Okay, and then 1 point to the left and 1 point to the right. Let's come look at our original equation. When we started it all, the a number, so right here it was, if we were going to complete the square, it would have been y equals x squared plus 12x plus 11. It's just that same one, only instead of equal to 0, equal to y. Had we completed the square, the y multiplier would have just been a 1. So there's no multiplier on that one. So over 1, up 1. So from the vertex, if we go over 1, that'd be negative 7. If we go over 1 the other way, it'd be negative 5. And then we're going up 1. So negative 25 up 1 is negative 24. And that one's not really going to plot that one. Okay, complete the square method. 22, complete the square method. Okay, so let's see, I'll move this over here to plus 4m squared. So we've really got 3m squared plus 6m plus 43. Okay. I'm going to move the 43 to the other side. Got to factor out the 3, so that's m squared plus 2m. Cut the b in half, square it in the whole. 1 squared is 1. So I added 1 to this side, but it's really times 3. So I added 3 to this side, I'll add 3 to that side. So we have 3, m plus 1 all squared equals negative 40. Okay, I'm going to divide both sides by 3. And now square root both sides. So those square roots go away. We have m plus 1 equals plus or minus imaginary square roots of 43rd. So there's going to be no zeros. If we move the 1 to the other side, it's really negative 1 plus or minus imaginary root 43rds. So we have no zeros. They're imaginary. All we got to do is find the vertex, and it's not going to have a 0. Okay, up here's the original equation way up here. The vertex is negative b over 2a, and then stick that in. So negative b is going to be negative 6 over 2 times 3. So it looks like the vertex, oops, sorry about that. Negative 6 over 6. So the vertex is at negative 1, and then we got to plug that in. So plug the negative 1 in there. So 3 times negative 1 squared plus 6 times negative 1 plus 43. That's 3 minus 6 plus 43. Looks like that's at 40. So there's our vertex, negative 140. So way up here somewhere. Okay, the y multiplier now is right there, times 3. So the y's are 3 times taller than normal. So when I would have gone over 1, up 1, I'm going to go over 1, up 3. Okay, so at negative 1, go over 1. That puts it at 0. Go over 1 the other way, puts it at negative 2. Then I got to go up 3. So over 1, up 3, over 1, up 3. It's way up here, which is why our formula told us there were no zeros. It never crosses the x-axis.